Hello and welcome, my pre-calculites, to your very first video lesson this year. I am going to be talking about the tremendous world of trigonometry today, and you should have in your little digits this packet. And this is your pre-printed notes. I'll be going through this. But since this is our first unit, I wanted to introduce you to the world of trigonometry and why we actually study trigonometry. It's very applied in the world we know. The very first way they calculated distance was called a transit. If you notice, there's a circular dial here that gives you angles, and they would calculate on a ship where they were relative to different locations, and that's how they navigated across the oceans. So they had this thing called a transit, and the modern day transit looks like this. You might see them on the side of the highways trying to figure out where the roads are going. So the Missouri Department of Transportation uses them. There's careers called survey engineers. When you buy a piece of property, they survey the land to find your corners of your property. Also, this is called triangulating your position. Here's the air flight, and if you remember the Malaysian airliner, I don't know, they keep saying, oh, we haven't found it. But how were they looking for it? These are satellites above the Earth, and they would take a signal, ping it to the satellite, and ping it to the airplane, and this is, you can see that these form triangles. So we're going to start with right triangle trigonometry, and then we're going to move into sine, cosine, and tangent, which is really the crux of how you triangulate a position and how a lot of GPS work. If you look at here, here's a calculated position. They measure this distance, and they can find all these distances in here by using the properties of trigonometry. It's kind of neat. So we just talked about what trigonometry is and how it's used in our world. We're going to find missing angles of triangles today, and we're also going to just start with the basics, locating opposite and adjacent sides in relation to a given angle, and identify parts of a right triangle. We're also going to use the Pythagorean Theorem. Now, I'm hoping that you all have had this before, so this should be a quick review, and let's get going. So here we go. Determine the measure of an angle. And what is that? It's like a zero with a line through it. Well, they're going to start throwing in some Greek letters. Theta is this O with a line through it. And the first three letters of the Greek alphabet are alpha, it looks like a little fish, beta, which looks like a B, a capital B, and gamma, which looks like an upside down fish. And then you have omega, which is the W looking thing. So the first three letters of the Greek alphabet are alpha, beta, gamma, and then delta is the fourth one. So have a good day. They were friendly even back then. So let's get started with this. Determining the measure of angle theta. You have to know that the angles of a triangle add up to 180 degrees. I know you guys know that already. So all you do is you sum these two angles and then subtract from 180. So angles of a triangle sum to 180. So we could set up an equation like this. And so we'd have theta plus 135 equals 180. Subtract 135 from both sides, and you'll get theta equals 45 degrees. Now let's get into labeling parts of a triangle. I don't like your packet in this respect. It uses capital letters for the sides. Usually sides are labeled with lowercase cursive looking letters. But for our example, it's going to be fine. But just keep that in mind. So it says side H is opposite blank. So which angle? Well, you go straight across from it. You see how 125 is opposite of that angle? A way to tell if a side is opposite of an angle, it should not form a part of the angle in a triangle. So if I look, R and 2 actually form this 125 degrees, but H is across the way from it. So side H is opposite 125 degrees. What side is opposite theta? Here again, theta is formed by H and R. Those are called adjacent sides. So the opposite side is across here at the 2 inches. R is opposite which angle? Well, it's opposite this angle beta, because beta is formed by H and 2, and those are called adjacent sides to beta. But the side opposite beta is R, so beta is your answer for that one. All right, finally, Pythagorean Theorem. Who's that square on the hypotenuse? So first off, do you know what the hypotenuse is? The hypotenuse is the longest side of your right triangle. It is opposite the right angle. So if you look across the right angle, this little corner almost points to it. That's called the hypotenuse. That the hypotenuse has always got to be the longest angle. If you recall from geometry, the shorter sides are opposite the smaller angles in a triangle. So we've got leg little b and leg little a. Another thing I want to say about this triangle, this is the classic right triangle, how it's labeled in trigonometry. You've got the angles are capital letters, and the sides opposite those angles, if you look, there's capital A, there's little a. There's capital B, across the way is little b. And then C is usually the right angle with little c being the hypotenuse. That is the classic labeling of a right triangle. So it's always going to be that way. Leg squared plus leg squared equals hypotenuse squared. That's the relationship of the Pythagorean theorem. And trigonometry is built on this fact. Everything is built on this fact in trigonometry. So a squared plus b squared equals c squared. You can also flip that around. C squared equals a squared plus b squared. So if we look at this next example, if we know two sides of a right triangle, we can find the third side. And we just plug it into this formula. Since we're looking for C, I'm going to use this bottom formula, and I'm going to say, okay, there's my hypotenuse. You might want to start by always labeling the hypotenuse a hypotenuse, because he's the guy that's going to be by himself. He's the biggest side. So C squared equals 5 squared plus 12 squared, and that'd be 25 plus 144. Remember that the squared means that number times itself. So we end up with c squared equaling 169. How do you get rid of the c squared? The opposite of squaring is rooting. So you have to take the root and you'll take the square root of both sides. Normally in algebra you say plus or minus, because you could say, for example, negative 2 times negative 2 is a positive 4. So we always put plus or minus. But we don't have to in this case because we're looking for the length of a side, and lengths of sides are always positive. So we can just take the principal square root, which is going to be 13. All right, next up, 2 and 3 and little c. I want you to try that one on your own, looking at the last example that I just did. Try that on your own. Pause the video right here. Okay, welcome back. Let's see how you did. So we're going to have 2 squared plus 3 squared equals c squared. We'd have 4 plus 9 equals c squared, and we'd end up with 13. Then you just take the root of both sides and you end up with square root of 13 equals c. Right now, just leave it as the square root of 13. All right, other application of the Pythagorean theorem is, you know two sides, you can find the third side. So in this case, we're going to be finding the length of a leg, which means they're going to give us the hypotenuse. Might want to label that right off. If you look here, here's our right angle. Opposite the right angle is 13. That's my hypotenuse. And I'm going to set up my equation. 13 squared equals b squared plus 12 squared. You could also put b squared plus 12 squared equals 13 squared. The difference here is you're going to have to solve for the b squared and then take the square root. So we square out those things. We get 169 equals b squared plus 144. And we're going to subtract the 144 from both sides to get b squared by itself. So we get b squared equals 25. Easy peasy lemon squeezy. B has to be 5. Example 2. Try this one on your own and see how you do. So pause the tape here. Well, it's not actually tape, it's video. So let's see how you did. So a squared plus 7 squared equals 9 squared. Because 9 is the hypotenuse. He's all by himself. He's the biggin. So we're going to take a squared plus 49 equals 81. We'd subtract 49 from both sides. And we get a squared equals 32. Root it. Now, some of you might have left it as the square root of 32. I want you to recall how to simplify these square roots. You look for the largest perfect square that goes into 32. In this case, 16 times 2 is 32. So we can break that apart and take the square root of 16 times the square root of 2, which is going to be 4 square roots of 2. This is called simplifying your square root, and I'm hoping you guys remember that from algebra. All right, that's it. I hope you enjoyed your first lesson, and I will see you later.